All right, so now let's continue. I'm moving into the section of the review that looks at half-angle formulas. These are a little harder at times, so just wanted to try a few more of these with you. So on 20, you're supposed to find the tangent of 105, and the directions say use a half-angle formula to get the exact value. So like 105 is not an angle on the unit circle. So the half angle formula has you do this, or has you think about this. Oops, let me mute my, okay. So we could think of 105 as being 210 divided by 2. 210 divided by 2 would equal 105. So we could do the tangent of 210 divided by 2. So we're going to be using a half angle formula, right? So let's go find that formula. So when you look down at the half angle sheets, you got some options on that. The tangent of some angle divided by 2, you have 3 different options. Do you see that? The first one, you have to make a choice about whether it's positive or negative. The last 2, it'll all come out when you work it. So you could do whichever of those you wanted to do. So for instance, if I chose to use, I would use one of the last 2 where you're not the one determining the positive or negative, because sometimes people forget to do that. Just go ahead and pick one of the last 2. All 3 of those are equivalent. Will give you the right answer. So the theta is the 210, okay? All right, so you're going to use the formula now with the alpha. The alpha is the 210. You're just going to use the formula with the 210 going where the alpha is supposed to go. So you're going to do 1 minus cosine 210 over sine of 210. Okay. So that's over here. Right there. So I'm going to look on the unit circle and get the cosine of 210. I could think about it. It's a special right triangle, but I might as well just look at the unit circle. So cosine of 210 is a negative square root of 3 over 2. Now be careful. The formula has a minus in it as well. So don't forget to put minus a negative or go ahead and say that'll be 1 plus. Now the sine of 210 is going to be a negative 1/2 down here. So this becomes 1 plus square root of 3 over 2, and down here we have the negative 1/2. All right, so what I've got again is those complex fractions that show up so much, and I'm noticing a denominator of 2 on both fractions. So I'm going to go ahead and multiply the top and the bottom by 2, and remember how that 2 gets distributed. So I like to just go ahead and distribute it if you don't mind. Okay, so then this is going to be 2 plus square root of 3 divided by negative 1. And see, that negative 1 can be distributed into each, divided into each, or I could have handled it a different way. I'll show you. So my final answer should be negative 2 minus the square root of 3. Up there, if I had thought about it, instead of multiplying by by 2, multiply by a negative 2 everywhere, and you'd get the same thing, wouldn't you? Negative 2 minus square root of 3, and then this in the denominator would be a positive 1, and that would give it to you as well. Okay, so I'm doing several problems I'll show you how to set things up, do the trig part, but the part that I'm most worried about is this part near the end. So I just wanted you to see several worked out. All right, so let's look at 21. It told us to use a half angle formula. Radians are a little bit harder to think about. We know 3 pi over 8 is not on the unit circle. They told me to use a half angle formula. So I've got to double that. And to double this, I need to multiply by 2. So that becomes 6 pi over 8. And that reduces to 3 pi over 4. Here's why we do it then. 3 pi over 4, that right there, okay, is a angle on the unit circle, okay, related to a 45-degree angle. So all I got to do is go find the formula. So sine of alpha over 2, that's going to be, now that one I have no choice, is plus or minus square root of 1 minus cosine alpha divided by 2. Okay, and plus or minus doesn't mean that you keep the plus or minus in there. You just have to decide whether it's the plus or the minus. And the decision about which of these, okay, depends on the original angle, the 3 pi over 8, okay? So really all you got to do is think about this right here. Think about how 3 pi over 8 is in the first quadrant. So this right here has to be a positive value. So when you do the formula, you'll use the positive on this one. Okay, so the formula says I'm going to have positive, I already decided. Then I'm going to do 1 minus the cosine of 3 pi over 4. And that's going to be divided by 2. So I've got some radical work to do on this. So I'm glad this came up. We haven't had a lot of work with that. Okay. And so cosine of 3 pi over 2, that's over in the second quadrant. Cosine is going to be negative square root of 2 over 2. The formula had a minus in it. Okay. And this radical is a big radical. So the 2 is still underneath that radical. Okay. All right. So that's 1 plus square root of 2 over 2, all divided by 2. Right. So I'm going to wind up multiplying inside here, trying to get rid of that. I'm going to multiply, look at that denominator, and I'm going to multiply here by 2 and here by 2. And that 2 has to get distributed, right? So I'm going to be multiplying not just that, but also this. All right, so that's one way to get rid of those denominators when you have a complex fraction. It's my favorite way to do it. So that's 2 plus the square root of 2, and then it's all over 4. Ooh, I like that. We don't want to leave radicals in the denominator. Okay, and basically that 4 is under the radical, but we're lucky because 4 is a perfect square. All right, so I wanted to show you that you'll sometimes get answers like this. And that's the final answer. That's as far as it goes. Okay, so you'll have that radical underneath another radical. And you may not have ever seen that. Okay, so that was number 21. Okay. So the half angle formulas, I think, are a little harder than all the rest of them because you have to make that decision about the sign, whether it's positive or negative, and you have to learn that what you're doing is taking the original angle and you double it so that when you turn around and divide by 2, this right here really is the same as that, okay? All right, so let's go do another one of those. So if we look at number 23, we have secant of theta equals negative 13/12, theta in quadrant 2, and our job is sine of theta over 2. And sine of theta over 2, according to the formula, should be plus or minus 1 minus the cosine of theta, all divided by 2. Okay. So we don't know what theta is. We don't know what the angle theta is, but we know theta is in quadrant 2. And so we're going to wind up looking in quadrant 2 and drawing our angle there, dropping the perpendicular. Secant is the reciprocal of cosine. So cosine would have been negative 12/13. So the 13 is there. The negative 12 should be on the adjacent side. And you need that missing piece. So x squared plus the negative 12 squared should equal the 13 squared. So that's the 169. So x would be positive or negative 5, and it's going to be the positive. Okay. All right. Now, once I get that, actually, I didn't even need that. Now that I look at it, this problem I could have done without actually finding that because all I need in the formula for the answer is the cosine. Okay. Now, let's talk about this issue. I want sine of theta over 2. So I need to know whether that's going to be positive or negative. And this is theta right here. This is theta. Okay. So theta over 2, I got to decide where it is. So if theta is in quadrant 2, then it's between 90 and 180, isn't it? Okay. So if I want theta divided by 2, let me put that in blue, then if I take half of all of that, it should fall between 45 and 90. So it should be somewhere in here, which means it's in the first quadrant. The sign would be positive. Okay, now this one you'd probably already know this. You'd have said the sign was positive even if you were thinking wrong, even if you were thinking over here. So you might be lucky, but this can be complicated sometimes. And so I wanted to share with you how you make that decision. So for instance, say the angle had been down here. So this is a what if, this isn't the actual problem. So what if they told me that the theta was in quadrant 3, then I'd be down here. This would be 13, this would be negative 12, this would be negative 5, okay? Theta's in quadrant 3, so that means theta was between 180 and 270, okay? You have to think about theta divided by 2, and notice that theta divided by 2 would be between 90 and 135. So it would be over here. And you see how if you're not careful, you can mess things up. So for instance, if I were doing something that involved sine, the signs would be different signs there. So this is how you determine what quadrant you are in, what quadrant your theta over 2 angle is in. Okay, and then you use that. Okay, so this right here depends on where theta divided by 2 is located, not where theta is located. All right, so it is going to be positive. We're going to go ahead and plug everything in. So we're going to get positive square root 1 minus, and why I said I didn't really need the picture is we actually can get cosine from secant. So it's 1 minus negative 12/13 all divided by 2. That's really plus. Okay. If I multiplied everywhere by 13 to get rid of that fraction, I'd have the square root of 13 plus 12 over 26, square root of 25 over 26. That'd be 5 over the square root of 26, and then I'd have to rationalize it. And I'd wind up with 5 square root of 26 over 26. There you have it. Okay, so that's problem number 23. Okay. All right, and then I wanted to do some equations on this video as well. Oh, and on question number 24, that one I wrote out the solution and posted it. But on 24, the original problem on the sheet had a cube, but I realized that the test generator let me pick that, but that our textbook didn't really have the identity that would enable you to figure that out. So change that to cosine x to the 4th power, cosine to the 4th x. That one you could work out, and I did that for you on the answer sheet, okay? All right, so I wanted to look at a couple problems. So like on 25, you're being asked to find all the solutions of this angle. I mean, of this this equation, which means find all the angles, all the x's. Okay. And so that, if it says that, that's when you do the plus, the plus 2n pi, or you do the plus n pi. You do that if it's cotangent or tangent. You do this if it is any of the other, sine, cosine, secant, or cosecant, because those have a period of 2 pi. These have a period of pi. So this involves cosine. It's weird. I've got cosine on both sides. So let me subtract that. And you got to get used to kind of, you'll never separate the cosine from the x, but treat that cosine x just like you would a variable when you're combining it. So these are like terms is what I'm thinking, but they're on opposite sides of the equal sign. You see that? So I'm just using basic equation solving skills. I'm going to subtract 4 cosine x from both sides. When I do, that's going to give me 2 cosine x plus 3 square root of 3 equals 2 square root of 3. Okay. Then I'm working first to getting that by itself. So I'm going to continue. I'm going to subtract 3 square root of 3 from both sides. And at this level, you don't have to show that. I just wanted to be really clear. So we have 2 cosine x equals negative square root of 3. Okay. So I'm going to divide by 2 now. I'm going to get cosine x, when I divide by 2 everywhere, equaling negative square root of 3 over 2. Now's where you go to your unit circle and you look for where did you see the cosine being negative square root of 3 over 2, and it should have been right here and right here. Okay, so this angle, that's going to be your 5 pi over 6. And this angle is going to be your 7 pi over 6. But I want all the solutions. So every time, so those are the first 2 times I hit it. But then if I rotate it again, I'd have those 2 again and rotate again. And I could rotate in either direction. So what you do is you write that extra little plus 2n pi on these. Okay. And so your answers would be all of these and the n, where n is an integer. So it means you can wrap around either in the positive direction or the negative direction. Okay. All right. Now, let's suppose that turned out to be when you got to here, you had a problem like this. This is kind of like what happens on 26. You got to here, and it just wanted you to solve on the interval. And on this one, the interval from 0 to 2 pi. Well, you do the same work, but your answer doesn't have the 2n pi piece. Then it would just be this or this. X could be either the 5 pi over 6 or the 7 pi over 6. You just are restricted to one rotation, and you would just put those 2 for your answers to that. Okay? All right. Now, number 27 is 27. That is one I want you to look at to make sure you're comfortable with. This one says on the interval from 0 to 2 pi, but it's going to have more angles than you think. Okay. So here's the way you handle this. Okay. If it weren't already to the point where you had cosine of some angle equaling a quantity like that, you would get it to that point. So in other words, if there was something out in front of here, you would divide it out of the way. Okay. But we're already to where we need to be. Now you're going to go to your unit circle. Cosine needs to be square root of 2 over 2. So square root of 2 over 2 is the cosine if you're in either the first or the fourth quadrant. Okay. And so you think about how that 2x either is going to equal pi over 4, or the 2x could go all the way around to here and be 7 pi over 4, right? But that happens every time you rotate either in the positive or negative direction. So add the 2n pi thing to that. Okay. So we don't want to know what 2x can be. We want to know what x can be. So what you need to do at this point is get just x here. So you're going to be dividing by 2 everywhere. So when you divide by 2, that's the same as multiplying by a half. So dividing by 2 is the same as multiplying by a half. I usually think of it as multiplying by a half because it's a little easier to work out. See, half of pi over 4, so I think of it like this, gives me pi over 8. Here the 2's go away and I just have n pi. Here I'll have 7 pi over 8 for a similar reason. If I had 7 pi over 4 and I multiplied by a half, then that's going to be 7 pi over 8. Okay, and then the 2's cancel out and I have plus just n pi. Okay, so those would be all the solutions, but you want the solutions within that interval. So you just start taking your n and you let it be 0. You don't let it be negative because you want things to be within one positive rotation. So you let n be 0. So you come in here and you plug a 0 in for the n. Let me not try to do it in color. Let me just do it. So that's pi over 8 plus 0 pi. Over here, it's 7 pi over 8 plus 0 pi. Of course, 0 pi is just 0, so that'll be one of your answers, so will that. Now you let n equal 1. Okay, and then you've got to put that together, so you have to think about how 1 pi is really 8 pi over 8, and pi over 8 plus 8 pi over 8 makes 9 pi over 8. Over here, when I add 8 pi over 8, I'm going to get 15 pi over 8. Okay, so there's 2 more answers. All right, so let's go ahead and do n equals 2. But notice when I do that, then I'm going to be adding 2 pi. So that's going to be too big. It's going to be more than 2 pi, and I'm trying to get things within 1 rotation. So x could be, so x, the solutions to that, x could equal pi over 8, 7 pi over 8, 9 pi over 8, or 15 pi over 8. Because if you did 2 times that, you'd have pi over 4. You'd have 7 pi over 4. 2 times that would be 9 pi over 4. And 2 times that would be 15 pi over 4. And when you look at that, here's pi over 4. Here's 7 pi over 4. Wouldn't 9 pi over 4 be back here? And wouldn't 15 pi over 4 be back here? Okay. So these are within the 0 to 2 pi. Those are between 0 and 2 pi. And then when you plug them into your formula here, those angles become these, and they would all have a cosine of any of those angles would turn out to be square root of 2 over 2. So that's kind of the logic of it. Okay. All right, this one's going to be a little long because I want to finish these. Okay, I'm not going to do 28 completely, but just making sure you remember that you sometimes have to factor. So like this one, when you have 2 different trig functions, you have to have a way of getting it to be, the trig functions would have to be isolated in 2 separate equations. So one way to do that sometimes is by factoring. So like if I take a tan x out, then here I would have secant x, and that tan would get distributed. Here I would have 2. Okay, so see how if the tan were distributed, I have that original equation. So once I've factored it, remember how you can set each factor equal to 0 like you do when you're factoring a quadratic? And then the secant x plus 2, I could write as secant x equals -2. And then what you got to do is think about, okay, well, where would tangent be 0? Let's just finish it. Where would tangent be 0? So you think about that, and you think about these spots right here. So tangent is sine over cosine. So you need the sine to be 0, right? So that you don't get undefined, you get 0. So that's going to actually be at 0 or at pi. And notice they say solve on the interval from bracket 0 to 2 pi parenthesis. So for the 0, so you put 0, you don't put 2 pi, okay? All right, now for secant, I would think about if secant is -2, secant of something is -2, then the cosine of it would be the reciprocal of that. So that would be -1/2. Then I'd think about where is my cosine going to be -1/2. So it's going to be like here and here. And so I would look at the unit circle and see, well, that's going to be at 2 pi over 3. And then if you go to here, so that's 1 pi over 3, 2 pi over 3, 3 pi over 3. Right here would be 4 pi over 3. 4 pi. 4 pi over 3. So you get those 4 answers. Okay. So you get 0, pi, 2 pi over 3, and 4 pi over 3 for this one. All right, with 29, you're going to have to factor, but it's a different situation. It's kind of difficult, I think, algebraically. See how I have cosine there, but then I have sine here, and I can't really factor at this point to separate them into two separate factors, but sometimes I have to use an identity. So for instance, this right here, I can use the Pythagorean identity to replace it with something involving sine. So I can say cosine squared x is 1 minus sine squared x. Okay, then I might want to just kind of clean things up a little bit. So one of the things I noticed is these are like terms. So I have negative sine squared x plus 2 sine x plus 3 equals 0. So think of this almost like a quadratic equation, like negative x squared plus 2x plus 3. You know, if you had a quadratic equation, you would factor, but it's harder to factor when that's negative. So it's always okay to multiply by -1 on both sides to make that first term positive. So I'm going to do that. So once I do that, then I'm going to have a situation like this, which is easy to factor. Only that's not what I have. I really have sine x everywhere there is an x, but it's the same idea. Just wanted you to kind of connect it back to that. So this would be sine squared x minus 2 sine x minus 3 equals 0. If I change it to that, it's a little easier for me to factor. So I know I'd have a sine x here and a sine x there. I'd have to have a 3 and a 1, and the 3 would need to be negative. Okay, make sure you got your factoring correct, and then just set each factor equal to 0. And then solve each of those equations by first getting the trig part isolated and then think about it. So where on the unit circle would the sine of your angle be equal to 3? Nothing. So nothing comes from there. That's not possible. Okay. But sine equals a -1 when I'm down here. So this one right here would be 3 pi over 2. And if I'm just dealing with one rotation like I am on that, that would be your only answer. So this one's not possible. The other one only has one answer. Okay, and then let's look at 30. 30 is a challenge because it's hard to think about because they're not in terms of pi. So this is the value. This right here is the value of the sine of some angle. And I know it's negative, okay? So I know that it's somewhere in the fourth or third quadrant, okay? So these are the angles I'm thinking about that I'm trying to find. So my angles are going to be this angle or this angle. All right, but now I'm just using my calculator. So these aren't going to be unit circle problems. We're supposed to use our calculator. So what I'm going to do is I know that x would equal the inverse sine of this negative 0.37. And inverse sine, remember, gives us, this is from that section 5.7, gives us back an angle in one of these quadrants. So it's going to give us an angle over here, but it's going to report it back, remember, as something between negative pi over 2 and pi over 2. Okay, so darn it, I don't have my calculator handy. All right, so we're going to go to our calculator. Let me do that real quick on my phone. Okay, so go to your calculator. You need to work this out with me and put in the 0.37 negative and go do the sine inverse. On my calculator, by the way, it's sine h when you do that. Okay, when you do, you get something close to that. Okay, remember that x is really your angle though, but you get something that seems like it's giving me back the very same thing. What it gives me back, and I'm going to keep a little more accuracy than they asked for, gives me back a negative 0.3785. I'll keep about 4 decimal places. Okay, that's not the value of sine, that's the angle whose sine would be negative 0.37. So it's just kind of a coincidence that it's so close, but that makes it complicated. So that angle right there is negative 0.3785. And it gave it to me because your sine inverse gives you something between, it gives you something here or here. So it gives you something between negative pi over 2 and pi over 2. but we're still trying to solve on the interval from 0 to 2 pi. So we got to modify that. So if that angle is negative 0.375, I could add to that, okay? I could find out then what that would be if I thought about it rather than, okay, let me draw this better. So if I thought about it rather than going this way, which is what it is now, if I went this way. So do you see how I could do that? Okay. What I could do is take, see this amount of rotation right here is the 0.3785. So couldn't I take 2 pi and subtract that 0.3785? So that's what I'm going to do now. I'm going to take that negative 0.3785 and add 2 pi. Okay, and I get 2 point, so I did 2 pi, and I really, on my calculator, really just added the 2 pi to what was already sitting there. And I wound up getting 2 point, well, that doesn't make sense. That should have been about 6. Oh, I think it didn't do 2 pi. I think it just did pi. So let me do that again. So let me do 2 times pi. I have to put the time symbol when I use my phone. Forgot about that. Then I'm going to put that minus 0.3785. And I get, so I had to put the actual time symbol if I'm using my phone. So see, 2 pi is about 6.28. And so when you do the minus 0.3785, you get 5.9, and it said 2 decimal places. So that right there, here would be the coterminal angle to this one that would be within one rotation, okay? And then over here, this right here amounts to 0.3785, and it's not this. That's not correct thinking. It's what we got when we did the inverse sine of that. And so see how that amount would be past pi? So for that one, take pi on your calculator and add to it the 0.3785, and that gives you this one. And this one right here turns out to be 3.52 about. What's hard about this is it doesn't feel like an angle, so it's hard to distinguish. This is the value of sine of some angle, and this is the angle itself. And they just happen to be really close in size, so that makes it complicated. Okay? And then you've got to think about, you need this angle, but you need it to be reported within one rotation. So rather than using the negative of it, you have to go this way with it. So I had to take 2 pi, and on my calculator I had to do 2 times pi to make it do what I wanted. And then add that to the negative 0.3785. Okay? So your answer to that one is the 3.52 and the 5.90.